Okay, hello everyone. Today I have here Gorazd from Calms. Hi Gorazd, how are you?
Hi, Elvira. I'm fine, thank you.
And Gorazd found the time today for our ARG movement platform to talk a little bit about the system, about your journey in compressed air. Could you please just introduce yourself, tell to our listeners, for those who don't know you, what do you do? How you? This is my first question. How did you end up in compressed air?
Okay, yeah, great question. Compressed air was actually not my first choice. I started with this together with my father. This is about 30 plus years ago. So I was somehow forced to enter this because it was like a family business. My father was mechanical engineer. He was expecting me to be the same, but I didn't want to be this. So I started with university as automation process engineer and computer science engineer. So that's my favorite part. Slowly over the years, I somehow managed to integrate those both fields: compressed air, mechanical part, and automation, service, complete service installation, and so on.
So you
So
basically
that's
were forced to compressed air, but you actually could use your favorite part, right? That you enjoyed the most, computer science
uh,
and control.
exactly, yes. I don't like dirty hands. Still, I always get dirty hands because I did all the hard work as well when learning compressors. I had to enter the compressor rooms, do the service of different machines. So yes, but actually my preferred hobby and interests were in computer science. So from the beginning, I was involved more on the control system of each compressor, different controllers, and then of course also master controllers when there were some special installations or requirements. I was slowly moving to this, what is my favorite process instrumentation and process automation, which is my favorite subject. So yes.
It's interesting. I think we have a lot in common because I work with my father and he is a computer scientist and I'm a mechanical engineer. So it's uh, it's
Okay.
it's it's a vice versa. He brings
Vice versa.
vice versa. He brings that part and I go and I bring the mechanical engineering part. Tell me, please, what is makes it so exciting, and why you think it's important to bring the what is the know-how that you bring in the compressed air with the new control strategies or with the new monitoring or energy management system? So, because it's very often compressed air considered as the very old-fashioned, like dying out technology that, of course, I don't believe in. But in general, when we see all the trends, we never see two phrases together, compressed air and IoT, or very, very rare, and or even compressed air and artificial intelligence. So people just like start to laugh, but I see that you are successfully implementing it with Calms. So what do you think where is the synergy comes together?
Yes, you are definitely right. Compressed air is old and not old-fashioned, but traditional industry, which is very slow in moving towards new technologies and new improvements, and is managed by large corporations. So we found somehow a different approach how to enter this, and of course, our passion, our goal was to create a holistical system for managing compressed air, starting from system assessment up to audits and permanent monitoring and asset management, reporting, and all that stuff. And when you join this together, then you need some tools, and of course, IT tools like computers, softwares, and now in the recent 1 year or 2 years, AI, of course, they help a lot, and the improvements that you can see in this is incredible. So yeah,
So
Okay.
Yeah. So maybe you could just explain and elaborate more on this control strategies that you use, or like this algorithms. Did you develop a new algorithms, or the strategies, or the idea of the holistic approach? Or and my question would be, as the question of our listeners, aren't like compressor suppliers should develop those kind of things to control compressed air room?
Yes, okay, where to start? Of course, they are doing this and they are creating their own stuff, but there is always conflict of interest, as you know. So if someone is trying to produce and to sell equipment, he cannot do also verification of this equipment and metering and optimization of this equipment, and he cannot say we are the best in class, because that's obviously some conflict of interest. And how we started actually is that we were focused on the demand side with leaks. So that's where we started. Actually 20 years ago, or 18 years ago, actually, I started a game between our local companies, factories in Slovenia, very small, tiny country. And the game was oriented for which company will find the most leaks. And then when this game started, there were more than 20 companies, a large one and a small one, competing against each other. And of course, the big factories, they found much more leaks than the small ones. So we said, okay, how can we compare those results? And then we decided, okay, maybe we should measure how much air they consume, and then we calculate the percentage. So that's how we started with the monitoring system, because we want to compare those stuff. And everything, the complete software was done on internet 15 years ago, or maybe even 20. And then slowly we improved step by step, adding features. We noticed what is necessary for customer to have a holistic approach. And the first next step, of course, was monitoring. So we were able to compare, this is the number of leaks, this is the size of leaks, and we can evaluate based on the actual repair, and we can compare, benchmark this to the complete air consumption. So yeah, it was a very interesting start.
So basically, the worst company won the prize. What was the prize?
Yeah, that's
Leak repair.
Leak repair. No, it was not, because that would be a conflict of interest. That was, yeah, there was a nice prize. Yeah, the first prize I remember was, we were working together with the Institute. We were preparing a book about the compressed air efficiencies and optimization. And I know that the first prize was, of course, this book and the energy management conference, which is every year in a nice hotel arrangement. So that was the first prize, yes.
Okay, not bad for the company who has the most amount of leaks. So, so basically, what I get from your explanation, what counts, that you are brand neutral, right? You are independent energy management system for compressed air, for compressor rooms, and that you also have the software also for leaks. So the leak detection is how does it work? That you have an auditor who then puts the amount of leaks and location in the software, and then the company repairs it, or how it is structured?
Yes, actually, the platform is web-based, so it means that the end user can use it together with external auditor. And as you mentioned, we are completely brand neutral. So it means that in our system, you can use any compressor, any brand. You can pick from the list of the database, and the same goes with the instrumentation. So actually in our lab, we tested about 10 or 12 different leak detectors, ultrasound leak detectors. We calibrated them for our approach for leak detection with the decibels, and then we corrected those data statistically based on the huge amount of leaks that were done in columns, more than 1,000 worldwide. Systems, and a lot of leaks which should be done every year. So we have different approach that can be done by, if you can outsource this to a specialist who can do the leak audit for you based on our calibration within columns. Or we can train, or you can train yourself, the end user, to do this internally. And this is, I think, in the future, a very good approach, because based on the leaks that can reoccur every moment, a new one. So this must be ongoing process, and internal process that will drive to this towards zero actually is based on the zones. So we divide the factory in different zones, and when the system detects that the baseline is going up, then they can start doing leak survey and leak repair just in this zone. So that's the approach, and everything is done, of course, with these ultrasound detectors.
Okay, I wanted to ask you, when you come to the company and you propose such a monitoring system, I'm not talking about the leak detection, but more on the control side of a compressor room. I often see that maintenance managers say, "Oh my God, it's another software. I need to now educate everyone here. It's another like dashboard, so I need also to understand what's going on." And in general, if we look at our industry, as you said, it's very traditional industry. There are experts, there are people inside the factory that kind of like take care of that. Sometimes they can consider that we criticize them. So when we find some leaks or so something negative part, and another part is that it feels for them that the life will be more complicated for them if they have another software for this kind of thing. So how do you deal with this kind of questions with your customers, and how do you explain them that it's actually will make the life easier and the moment you just like learn how to use it?
Yeah, this is definitely a great challenge because, as you know, as you mentioned, in each company they have multiple tons of different software, starting with the simple SCADA and going up to energy management software and dedicated software for different stuff. So yes, how we manage this, we try to create a very simple Android or a mobile phone application that can be used in field, and easily with press of button synchronize all the data to the cloud. And the cloud platform was designed and tested and all written on the front end several times. With the many end user complaints and improvements. So it's very intuitive and very easy to use. Although now we add a lot of different, let's say, steps in the improvements. So it's not just the leaks, or we call it waste, because it's not just the leaks. It's also artificial demand and inappropriate uses identification, which is our package called as a waste. But yes, how to train them? It's actually that's a good topic for the new technology. It's now the AI. So right now we are working on a nice feature which is very easy to do actually with an AI. How to train end user to use the application. So we built half a year ago. We created our own columns GPT. So yes, it was trained by our database of knowledge of compressed air and about columns platform documentation. So anytime you can ask our guide, how can I do that? What is the decibel meaning? How far should I measure this? Where can I get the reports? How the reports can be created automatically, and so on. So these new features, actually, right now we are working to improve this with short videos, which are also mostly AI generated. So yes, this new technology is helping quite a lot to improve those.
That sounds really interesting. I'm such a fan of the AI and machine learning. And yeah, I would like maybe to elaborate more. So you see that it's mostly that you trained your database basically to answer the questions of auditors. So it's more like on the like a personal assistant rather than the interpreting data, or it's both. It first interprets also data, can analyze the measurement, and then gives advices of that. Or we still need an operator or energy manager who will ask the question. You know what I mean?
Of course, you need some user on the platform. If you don't have any user, just AI talking with themselves, it's not a good idea. So yes, the end user who is using this platform for optimizing and getting the best system compared. The good thing is that our systems are compared between each other based on isentropic efficiency. This is pure calculation, so no questions about AI or difficult questions. But our platform is collecting data from measurements, from system assessment, so system reviews, and from waste management, and from audits and asset management. So different parts are feeding the data in. And what we are working now on is actually to feed all this data to the models and together with the documentation of our platform. And if you have a question, then you can ask also specifically for your system, how can I improve my system? How can I calculate this? And then the system will not do complete procedure for you. Okay, he can link you to an expert who will help you, or he will just give you a hint, use this calculator, use this tool or this is the way how it goes. So this is the simplest way of how to use artificial intelligence in our platform. Another, which is a little bit more complicated, are auto analyzers. So those are the small services that are running within our platform, and they are actually using also artificial intelligence to create the new services and to learn on all the data that are coming from different measurements all over the world, and can help identify, let's say, unloading problem or too high pressure or spikes and so on. They are not perfect yet, they are far from that, but they can actually reduce the time for an expert who will get an alert. Now you need to do something. You have to focus on this short region reporting period and improve it and check what's going on. So experts are still needed very much, and also in the future. I don't think this will change, but it is definitely the future, because this is very time consuming. You can imagine Excel table with sample rate of 1 or 5 seconds data for 1 week. I mean, you need 1 week to go through all these lines and columns. So with those tools, you can find very easily anomalies and find some where you have to focus then.
Yeah. And is it industry specific? Do you also divide this by the type of the industry? For example, automotive, automation, food and beverage, or cement, like petrochemical industries. So does it have also some specifics for that?
Yes. Unfortunately, we decided that this would be a good idea half a year ago. So yes, whenever you create a system in the platform, you select also which type of industry you are in, so that we can also easily identify and reduce the amount of different solutions in different industries. For example, now we are comparing statistically because our platform has the biggest database based on leaks. Okay, so we are now trying to get some insight, some let's say Gaussian chart, where each system is located based on the percentage of leaks. And we will compare then this also related to different industry sectors. That's our goal, yes.
That's that's really great. I wish you all the luck with the AI, and I'm really excited to see where it's going. Talking about the future, since we're already talking about the future,
Yes.
so what do you think, in your opinion, as the really big, you're so passionate about the IoT and the machine learning, and you come from that field. But what do you think what's going to happen with compressed air industry in the 10, 20 years run? Like, have you thought about it? What are the trends in your opinion? Like, or what your clients say about it? Like, do people want to go into the electrification, or people are still happy about the compressed air? So it's interesting to know your opinion.
I need to survive in this industry for 10 years more, so that will happen. But I see that the compressed air usage will definitely not gone. I mean, it will be present. Of course, a lot of equipment will be electrified replaced by electrical tools or some other tools as well. But there is a lot of process air and also instrument air which cannot be replaced, or it does not make sense to be replaced. So I think this will be present also in the future, and the future will also use a lot of those new tools, especially with, for example, new directives which will come, I guess, the energy directives for energy efficiency, and also maybe the potential that we can use with the forecasting of energy consumption, and maybe storing the energy in the compressed air. If you would be able to manage this and store those spikes, then the electricity bill in the near future, very near future, might look very different than if you will not use those technology, like forecasting electricity consumption, and okay, 10% of this goes also to compressed air. So yeah, we are playing also with this future potential of compressed air, especially in relation with the controls, together with the flow controllers, huge receivers, tanks. In some companies, already now in one chemical plant, they have about 200 cubic meter receivers, and they can store for about 5 minutes, and there are 15-minute spikes of electricity. Its centrifugal compressor is 850 kilowatt, and they can stop this one based on the electricity consumption for maybe 5 minutes. And they will avoid all those penalties in electricity bill. So I think this is also the future.
Okay. And may I ask a more maybe technical question? Because in the storage, you usually need to have a certain pressure difference to operate the system. So is it and to have this like the sometimes like for very big, large storages, the pressure difference has to be higher, and then it means that the compressor has to work on the higher pressure level that cause higher energy cost. So is it like still better and economically better to have the biggest storage? I mean, I understand that it depends on the system, but just from your experience, like bigger storage that can cover those energy spikes, or it's better to have a compressor with a lower pressure, but with a medium like tank size. So I know that it's a bit of calculation for every application is specific, but I'm just curious what companies
It is, but in the future, I think this will be the same like with the hydropower plants that are building uphill and storing a huge amount of water, pumping this water during the night, and then during the day they can use this energy stored during the night, and that can be exactly the same with the compressed air. So this I'm talking this in the very near future. Yeah. So maybe even if you would decide to run the compressors with a higher pressure, that of course is costing more money. But if this time period for a spike is 15 minutes, and you are not above this, you can pump the air and store the energy with a lower price, and then you can use this to reduce this price. But the forecasting of complete energy consumption, electricity, must be very accurate in order to be able to calculate those potential savings in the future.
Yeah, it's very interesting. Very interesting. I haven't thought myself about this approach. So basically, you need to communicate then your control system together with the general energy management system that has this price forecasting, right?
Yes. We already are working with one institute. They are doing the forecast of all energy utilities like gas, electricity in general, and we are working on our side on a compressed air. And then joining those two information together, we are able to calculate when it's better to store energy, potential energy, even with higher specific power in the receivers tanks, and use this potential energy in the future when you will need to cover the spikes. So yeah, that would be interesting.
Okay, I'm very excited to see that you're really making some like many interesting breakthrough technologies for compressed air industry. Just the question, how it is received by your clients and by, for example, compressed air suppliers? Do you think it's more like the competitive market for you? You mentioned before you still need to survive 10 years more on that, and we hope that compressed air will be used. Like, what do you think in general about the compressed air industry? Is it more collaborative? Is it more competitive? Is it like how you perceive this?
Yeah, we are lucky that we are small, so we are not noticed by the big ones. At least when we are, we might have some problems, but we are brand neutral, so actually there is no conflict of interest. Actually, when we see that they can offer a good solution, we of course, together with independent experts who are using this platform, these tools, can use it, of course. So I don't see any big problems with this, and but there is also no direct cooperation. For example, we ask few manufacturers if they would deliver us the data sheets about their machines, so that we can put this in our databases for simulations. And most of them, they were not very happy to share this information with us. So we had to find those type of data sheets somewhere else, or measure them, or get them from KGI or some other agency. Or
okay, is it you mean of compressors?
yeah, I mean the data sheets of different brands, because we have in the system, I don't know, 10,000 different compressor models, which we need for simulations. If you don't have the real data in the database, it's impossible to simulate the new compressed air system. So we needed those data, and it's coming all the time, of course. But it's not so easy just to call the big one and can you provide me the data sheets of all your compressors? They will not do that.
Because this kind of data should be available, right? It's like a technical, it's not something very detailed. It should be available online, so it's not a know-how sharing, I guess.
I would say so, yes, but unfortunately it's not. And a lot of hidden information, as you know, how the flow will be measured. Okay, they're all using ISO standards, but still, this is not enough.
Yes, of course. Yeah, no, it's interesting. And what do you think is then the future of compressed air? So besides the AI and smart assistants, so is it like more in the collaboration and maybe education of people? Because I see there is still like a lack of awareness in general, what exists on the market, on the training, on the education, but high quality, I mean, you know, that covers the holistic approach. So what do you think should be done by the industry in the next couple of years to make it, to show that technology is not like, it's actually efficient if you use it in the right way? So this is how I feel. So what do you think?
Yeah, I agree absolutely with this, that employee engagement and everyone is very important. So that's also one of our holistical approach. So you have to speak the same language with the end user, and you need to explain how to compare different systems, that why it's not possible to compare based on specific power, but you need to use isentropic efficiency, for example, because of different pressure and temperature and so on. So I think that education is very important, and I think that also independent experts, they figure this out, and they are running different training classes, at least for their customers, before they start working on an energy audit. They do at least short 2 hours educational training, and yes, definitely this is important, very important part. We call this actually, last year I heard from one company in US, they were talking about employee engagement, how important this is if you want to be Energy Star. I was thinking about this, how to incorporate this into our holistical approach, and actually we figure out that this is the most important part. If you want to get feedback from the factory what is wrong, you have to ask the employee there on their workplace. So we actually added a new feature to our platform to collect the data based on the simple QR code registration and to reward them somehow. That's something we didn't figure out how, but they are the ones who should be involved. And when they do that, they will get also short videos how to be trained to understand what are the potential savings in the compressed air, but also other utilities, or maybe a safety issue as well. So this is everything part of training. Very important part, yes.
Yeah, no, that's great. That's great, Gorazd. I really can't wait to talk with your Calm's GPT assistant about optimization of compressed air. So I think this is really something very, very exciting. And thank you so much for doing such a great job. And thank you so much for coming today.
Please do not use the one on the web page, because this one is trained to sell columns. So you have to use the one that is inside the columns. It's a different one.
Okay.
So, yes. Okay.
But this is also good. Some sales assistants, it's also very nice.
Yeah,
very
it's a
nice
sales assistant. Yeah, the one, yes.
Okay, perfect. Thank you so much, Gorazd.
Okay, thank you. Bye.